Hello everyone, I'm Ezgi from Bilkent University Electrical and Electronics Engineering Department. Today I'll be presenting my analog CMOS integrated circuits project, which is to design an 8-bit DNA converter. Here are the project specifications that are pretty long and in detail. To save some time, I will pass these, however, revisit them in some places of the project. For the project part 1, the following topology was used for the op-amp in the converter, and later it was drawn on Cadence schematic drawer so that it will meet some specifications, and these resistor values, capacitor values, as well as the width and length of the MOSFETs were designed such that these specifications were met. Here you can see the phase margin, no load current, gain values, and output impedance of the op-amp. The gain value was not specified, however, 65 dBs are considered good for this design. The phase margin is seen to be more than 50 degrees. No load current was specified to be less than 10 milliamperes, so it was met, and the output impedance was also seen to be less than 3 ohms. So for the project part 2, the R to 2R ladder was done, and later the circuit was tested under 27 degrees and 50 degrees conditions. First, the output of the DNA when input increments from all zeros to all ones in 256 steps was observed. The importance in this is that the monotonicity was also observed, so the steps should be equal in these parts, and the spikes should not affect the voltage values of the steps. So the spikes were in time duration was very small and considered unimportant. Also, the output of the DNA inverse power and 50 Celsius was observed too. And without losing any bits, the converter can work up to a clock of 263 kilohertz was measured. Later, the Monte Carlo analysis for voltage step size was done. So it was seen that a mean of approximately 11 millivolts was observed in step size. If you look back to the specifications, you can see that it should be actually theoretically 15 millivolts. However, 11 millivolts, actually up to like 9.8 millivolts is deemed acceptable. Also, Monte Carlo analysis for PSSR was done, and it was seen that the circuit had nearly 40 dB PSSR. And for the project part 3, all of these designs were converted in the layouts. So first, the op-amp was converted in the layouts, and no DRC errors as well as no LVS errors were found in the process. And also, actually, the layout of the op-amp in Cadence is 0.03 millimeters approximately. In addition to that, the layout of the converter was done too, and it was actually covered the space of 0.2 millimeters. Later, this whole design was converted into a symbol, as you can see in the picture. And the whole procedure was done by extracting the R parasitics. So the step size of the DNA converter was measured again, and it was seen to be 11 millivolts again. And the linear output versus input characteristics were observed too. Later, it was checked that phase margin is again bigger than 50 degrees, and the PSSR of the converter is again acceptable, which is actually 73 dB in the lower frequencies. And by this way, the whole design was completed, and thank you for listening to me.